All right, today we've got an absolutely wild story for you. It's about a time when top-secret Cold War technology and your neighborhood pool hall crashed into each other in the most amazing way. This is the story of one of the world's very first interactive computer games. And believe it or not, it was born on a machine that was built for war.
So, I gotta ask you, what in the world could a computer designed to guide missiles possibly have in common with a game of 8-ball? I know, it sounds like the setup to a really weird joke, but the answer is actually a super fascinating piece of tech history.
Because get this, way back in 1954, years and years before the first arcade games, a fully playable pool simulation flickered to life on a screen. And this wasn't running on some computer in a university lab for students to mess around with. No, this was happening on a highly classified special-purpose military computer.
To really get how this happened, first, we've got to understand the machine itself. So let's rewind the clock a little bit, back to the years right after World War II.
So, picture this. In Michigan, there's a town that was famous for building bombers during the war. After the war, it starts transforming into a research hub. The University of Michigan there gets a ton of funding from the U.S. Air Force to dive into this new frontier called digital computing. And that leads to a big contract from Boeing for a very, very specific machine.
Now, here's the key thing you need to know. There were actually two computers, kind of like siblings. You had the MIDSAC, which was a general-purpose machine. It ran some simple stuff, early games like tic-tac-toe. But the new machine, MIDSAC. Oh, MIDSAC was a whole different beast. It was a special-purpose computer, built for one job and one job only, doing real-time calculations to guide aircraft and missiles. Yeah, this was serious, top-secret stuff.
But even the most serious projects have people behind them. And in this case, the people involved had a passion that went way beyond military calculations.
So, let's meet our heroes, William Brown and Ted Lewis. These guys were research assistants at the university. In the fall of '53, they get this really important task: create a live demo to show off what this powerful new MIDSAC computer could actually do. And as luck would have it, both of them were huge fans of playing pool. So, put yourself in their shoes for a second. They had this massive problem. It's 1954. Most people have never even seen a computer, let alone one that guides missiles. How in the world do you show people what this complex, abstract machine is capable of in a way they can actually understand? And their solution? It was absolutely brilliant. They figured, hey, instead of showing everyone a bunch of boring code or complicated math, let's use a game literally everyone gets: pool. They decided to build an interactive simulation that would translate MIDSAC's intense physics calculations into the simple visual language of balls bouncing around a table.
But here's the thing. Trying to build a game on hardware that was never, ever meant for it, that took some serious, next-level ingenuity. Their whole process was just a masterclass in creative problem-solving.
And what they pulled off was just wow. It was incredibly advanced for the time. I mean, don't think of this as some little blip on a screen. No, this was the whole shebang, a full 15-ball simulation with a cue stick you could actually control. The ball collisions were based on real physics, the graphics were drawn with vector scanning, and the whole thing was displayed on a spare 13-inch screen they literally just found lying around the lab.
Okay, but this is my favorite part of the whole story, the hack. See, the computer had just enough memory to do the physics and draw the balls, but it couldn't draw the table itself. Not enough juice. So what they do? They put a physical sheet of plastic over the screen and just drew the table boundaries and the pockets on it by hand with a grease pencil. A brilliant, low-tech solution to a super high-tech problem. I love that.
So, how well did it run? Well, after working out a few kinks, the program actually stabilized at a remarkably smooth 10 frames per second. Now, that might not sound like a lot today, but for 1954, that was a fantastic achievement.
And get this, this wasn't just some demo you watched. It was fully interactive. You could actually play it. Players had a small joystick and a knob to line up their shot, a button to hit the ball, and they even had a second button to reset the cue ball if you made a foul. This was a real, honest-to-goodness, playable game.
All right, so you've built this amazing thing on a top-secret computer. You can't just keep that to yourself, right? The team knew they were onto something huge, and they got ready to show it to the world.
I mean, just think about that journey for a second. This whole thing went from being part of a classified military project to a public spectacle that was basically giving everyone a sneak peek at the future of entertainment.
The big day was June 26, 1954. Over at the university's Cooley Laboratory, journalists and a bunch of curious people all gathered around to see this strange and wonderful creation for the very first time.
And this wasn't something they just threw together over a weekend.
It took them almost 7 months of hard work to get this demo ready, first for a computer conference and then for the general public. That just shows you how much effort they put into turning this really technical concept into something everyone could enjoy.
So when you look back at it all, from this one clever demo for a military computer to the multi-billion-dollar global industry we have today, the story of the MIDSAC pool game is so much more than just fun trivia. It really makes you wonder, what does this forgotten project tell us about the hidden power of play? How creativity can just pop up in the most unexpected places and completely redefine what we use our technology for?